Hello guys, I am Akshay Pattan and I am from Team Merchant Navy Decoded. I have cleared many sponsorships like Anglo Eastern, Great Eastern, Samudra Institute, Seven Islands, and V Ships as well. So today I am here to take a technical discussion on IC engines. So hope all are doing fine. So guys, can anyone say me what are the types of IC engines? How the IC engines are classified? Anyone? Hello.
There are two type of IC engines, sir. One is spark ignition, again one is compression ignition.
Okay.
Mm,
What do you mean by
and
spark ignition engine?
in spark ignition, spark is produced to ignite the fuel.
Okay. And in compression ignition?
In compression ignition, we compresses the air to a high temperature and pressure, and then we spray the fuel from fuel valve from nozzle into the fine spray.
Okay. Yeah. So this is the general classification of IC engines. So now we'll talk about the
Yes, sir.
engine which is used on board ship. Okay. So guys, can you tell me why the engine is used on board ship? Why engine is required on ship?
Sir, to propel the ship forward.
Okay. To propel the ship only in the forward direction?
No, forward as well as to the backward direction also. And there are many things producing steam and refrigeration unit. In such places, we use the engine.
Okay. So basically engine is used to propel the ship, right? So today we are going to discuss about the basic introduction of IC engines. We will not go in a deep technical knowledge today. As this is the first technical session, we will just discuss about the basic concepts of IC engine. Okay.
Sure,
So
sir.
yeah. I urge all of you to take active participation and speak up, guys. If you have any doubts, you can ask me once I finish explaining the topics, or in between also, you can ask me if you have any doubts. Okay.
Sure, sir.
Yeah.
Yes, sir.
So yeah. So the topic of discussion today is on IC engines based on Dreamers package. Hope everyone is having Dreamers package from Merchant New Decoded. So based on that Dreamers package, we are going to cover the topics of IC engine today. Okay.
Okay, sir.
So today's topic of discussion is basic introduction to IC engines, in which we are going to study about basic important terms of IC engines, and we are going to study the classification of IC engines. Okay. So first, let us
Okay, sir.
begin with basic important terms of IC engines. Guys, the basic important terms include stroke length, bore diameter, mean piston speed, and compression ratio. Okay. Can anyone tell me what do you mean by stroke length?
Sir, when piston moves from
Distance between
BDC to TDC, then we can call it stroke length. Yes.
Okay. Any other one? Any other guys wants to improve his answer or wants to tell the answer in different way? What do you mean by stroke length?
So distance traveled by piston in one stroke.
Okay. Distance traveled by piston in one stroke. Okay. Any other answers? Okay, no issues. We will discuss it in the next slide. So, what do you mean by bore, guys? Anyone?
So diameter.
Sir, it is the diameter
diameter
of
of
piston.
liner,
Diameter of piston.
Liner,
No,
sir.
no, sir. It is the diameter of
The
cylinder, sir.
entire
Sorry, sir.
piston.
Yeah, yeah. Ask. Who has question?
শাশ্বত রয়.
Yeah, yeah. Tell me. Yes, Ashwat. What question do you have?
Bore is the inner dia of the piston.
Okay. Bore is the inner dia of the piston.
Yes, yes.
Okay. Guys, is this a correct answer or wrong answer?
Sir, actually, it is the diameter of liner, inner diameter of liner.
Okay. Inner diameter of liner. Okay. Um, we will discuss it. So, guys, what do you mean by mean piston speed? Anyone?
Sir, the average speed of piston when it moves from BDC to TDC is known as mean piston speed.
The average speed of piston when it moves from BDC to TDC, right? Okay.
Yeah.
Yeah, we will discuss the mean piston speed. I have written all the definitions in the next slide, guys. I just want to know what all you know about these topics. So that's why first I will ask you, and then later on we will discuss about those topics in detail. I have the definition with slides. Okay. Now, can anyone tell me what do you mean by compression ratio?
Sir, the compression ratio is the ratio between the volume of the cylinder and compression chamber in the internal combustion engine.
Okay, the answer was not that clear, Sashwat. Anyone, any other people who want to explain the definition of compression ratio?
It's the ratio of the total volume of the cylinder to the clearance volume of the cylinder.
Okay, total volume of the cylinder to the clearance volume of the cylinder. Okay, so this is the definition for something else, Sam, not
Hello, sir.
Okay.
compression ratio. This is not compression ratio. That is some other ratio you are telling about. Anyone else? What do you mean by compression ratio?
Sir, it is the ratio of mm, volume of cylinder at BDC to the volume of cylinder at TDC.
Correct. It is the ratio of volume of cylinder at BDC to the volume of cylinder when the piston is at TDC. Correct.
Yes, sir.
Yeah, Harish, that is the correct definition of compression ratio. So now we will look at the proper definitions in the next slide. Okay. Yeah. So here is the definition for stroke length. Well, stroke length is the distance traveled by the piston from BDC to TDC. Okay. When the piston is at BDC, that is bottom dead center, and when it moves to the TDC, the distance which it covers from BDC to TDC is known as stroke length. Okay, you can see in the diagram. I have mentioned the stroke there. Stroke is mentioned here, right? When the piston is at BDC, that is at the bottom dead center, and when the piston moves to the TDC, the distance traveled by the piston is known as the stroke length. Can you guys zoom that slide in your phones?
Yes, sir.
Yeah. You can zoom it and see there. BDC to TDC, the stroke length is mentioned there as a stroke. So that is the definition of stroke length. The piston, when it travels from BDC to TDC, the distance which it covers while traveling from BDC to TDC is known as the stroke length. Is there any doubt in this?
No, sir.
Okay. Uh, Next term is TDC and BDC. What do you mean by TDC and BDC?
Sir, top dead center and bottom dead center.
Yeah. TDC is top dead center and BDC is bottom dead center, right? So this is a very basics which you are discussing today, guys. So please participate actively. I urge all of you to speak. If you guys have any doubt, then you can ask. Is there any doubt in stroke length? Is anyone who did not understand what do you mean by stroke length?
No, sir. No, no at all.
Okay, so shall we continue to the next part? There
Yeah.
is no doubt about stroke length, right?
Yes, sir.
Now we will discuss about bore. What do you mean by bore, guys?
It is the diameter of liner, sir. Inner diameter of liner.
Yeah, it is the inner diameter of the liner or the cylinder. That is known as bore. Someone said it is the diameter of the piston, inner diameter of the piston. No. Bore is the diameter of the cylinder or the liner. Okay. If you cut this diagram from top view in the cross section, the circular area which you get, inner circular area is the bore diameter of that cylinder. Okay. Is this clear or is there any doubt in this? Is there any doubt about bore? What do you mean by bore diameter?
No, sir. It is
No, sir.
clear.
Okay. Next one is mean piston speed. Someone said that mean piston speed is the average speed of the piston in a stroke, in one stroke, right? Actually, mean piston speed is the average piston speed throughout the cycle. Okay.
Yes, sir.
Yeah. It is the average piston speed when the piston moves from TDC to BDC in the suction stroke, and again it moves to the TDC in the compression stroke, and again it moves to the BDC in the exhaust power stroke and in the exhaust stroke. Okay, so it completes the one cycle in the four-stroke cycle. When the piston moves from TDC to BDC throughout the cycle, the average speed of that piston is known as the mean piston speed. Okay. Is it clear or is there any doubt?
Clear, sir.
Yes, sir.
Yeah. So the formula to calculate the mean piston speed is 2 into stroke into n. That is number of revolutions. N is the number of revolutions. Okay. Divided by 60. So this is the standard formula to calculate the mean piston speed. Okay. So next one is the compression ratio. As I said, compression ratio, it is the volume of cylinder when the piston is at BDC, that is when the piston is at bottom dead center. This is a cylinder. When the piston is at the bottom dead center, we have got the volume of certain volume of cylinder to the ratio of when the piston is at TDC, that is at the top dead center. It is the volume of cylinder when the piston is at BDC to the volume of cylinder when the piston is at TDC. It is its ratio. That ratio is known as compression ratio. Okay. Is there any doubt about this? Yeah,
No,
sir.
sir.
No, sir.
Uh, Sir, when the piston is at bottom dead center,
Okay.
it will be the total volume of the cylinder, right?
Yeah. Okay. Yes.
And when the piston is at the top dead center, it will be the clearance volume.
No, it will be the minimum volume of the cylinder. Clearance volume is different, and the piston when it is at TDC, it is the minimum volume of the cylinder because exhaust gases are also there when the piston is at TDC. After exhaust
Okay,
gas exits the chamber or exits the cylinder from the exhaust port, then you will get the minimum value, that is the clearance volume. Okay,
okay.
are you getting this? Because there is
Yes,
certain
yes.
amount of volume when the piston is at TDC, that is exhaust gases are there. That exhaust gases needs to go out
Sure.
of the cylinder, right?
Yes.
Then when the exhaust gases are still inside the cylinder, then it occupies some certain amount of volume.
Yeah.
So it is the ratio of cylinder when the piston is at BDC and to the ratio to the cylinder volume when the piston is at TDC, that is top dead center. Okay.
Okay, sir.
Yeah. So is there any doubt in these terms? These were the basic terms: stroke length, bore diameter, TDC, BDC, compression ratio, and mean piston speed. So these were the basic terms of the IC engines. Is there any doubt about this?
No, sir.
Yeah. Okay. So shall we move forward?
Yes.
Guys, can anyone tell me how do you classify engines, IC engines? How do you classify the types of IC engines? Anyone?
Sir, according to stroke, it is of two type.
Okay.
Two stroke engine, four stroke engine. According to fuel, yeah, according to fuel, it is a diesel engine and petrol engine.
Okay.
Um, uh,
So it can be classified on the basis of piston arrangement. It can also be classified on the basis of movement, uh, like rotary and reciprocating.
Rotary and reciprocating.
Reciprocating IC engines as well as rotary engines.
Rotary IC engine. I have not heard of rotary IC engine because piston itself uh, reciprocates and crankshaft converts that reciprocation into rotary motion.
The internal combustion engine and external combustion engine.
Okay, that is different types of engine. Okay, internal combustion engine and external combustion engines. We are talking about types of different IC engines. How do you classify different types of IC engines? On basis of what?
Sir,
Um,
naturally aspired and supercharged.
okay, based on aspiration, that is air intake, based on air intake, that is naturally
Sir,
aspirated and supercharged. Okay,
another is single cylinder or multi-cylinder.
okay, based on
Then
number of
the
cylinders.
yes, sir, and the engine alignment like V shape in V movement and W and X and low speed engine, medium speed engine, high speed engine, and another is reversible and bidirectional engine. Sir, this all I know.
Okay, reversible and bidirectional. I
Sir, no,
think
sir,
both are similar.
unidirectional, bidirectional.
Yeah, unidirectional and
Sir,
reversible, right?
yeah, sir, I spell mistakenly.
Yeah. Okay, it's okay, no issues. Anyone, do you want to mention any other classifications based on some other terms? Harsh mentioned about piston pattern, that is V, X, and Y, and he mentioned about speed, RPM, engine RPM. Is there any other type of classification you guys know or you want to say? Okay, so shall we move to that part of classification? So here is the classification of engines that is based on stroke cycle. As someone said, there are two-stroke engine and four-stroke engine. Okay, that is based on stroke. And next one is based on fuel used. What type of fuel are you using? Okay. Then next one is based on action. Single acting cylinder, double acting engine, single acting engine. So that is a type of action. And second one, and another one is, sorry guys, just a second. Yes. Another one is based on cylinder pattern, that is VXY or piston pattern. And another one is based on mean piston speed, that is what is the mean piston speed. There are classification based on that also. And another one is based on RPM, medium speed, high speed, low speed. Okay. So these are the classifications of IC engines. Okay. So we will look into those one by one. So first one is two-stroke engine. Can anyone say me the definition of two-stroke engine? Anybody? What do you mean by two-stroke engine?
Sir, the whole cycle is completed in one revolution of crankshaft.
Okay.
in which the compression and suction and compression take place, and another expansion and power stroke and your exhaust.
Okay. So any other people who want to say the definition of two-stroke engine? What do you mean by two-stroke engine? Or what do you understand by two-stroke engine? Anyone? Okay. So let us see what the two-stroke engine is. Yeah. Two-stroke engine is a type of internal combustion engine, guys. It is a type of internal combustion engine which completes its power cycle with two strokes of the piston, during which only one crankshaft revolution takes place. Okay. Two-stroke engine, actually the piston travels from TDC to BDC and from BDC to TDC only twice, and one cycle is completed. That is, one revolution of crankshaft is completed, and the whole cycle is completed in two strokes only. So that is two-stroke engine. In two-stroke engine, we don't have valves, we have ports instead. Can you guys see that diagram? Can you guys zoom into that diagram? Here we have a diagram of two-stroke engine. Can you guys see there? We have the ports, exhaust port and inlet port. We are not having the valves here. Where in four-stroke engine, we have got the valves. We don't have the ports. Guys, is there any doubt in two-stroke? What do you mean by two-stroke? Anyone?
No, sir.
Okay. So this was about two-stroke engine. In two-stroke, the whole cycle is completed in two strokes of the piston, and one crankshaft revolution takes place in only two strokes. That is the two-stroke engine. Okay. So next one is four-stroke engine. What do you mean by four-stroke engine, guys?
Sir, in four-stroke engine, the working cycle is completed in four strokes of the piston or two revolution of the crankshafts.
Okay. Can you tell me what are the four strokes?
Sir, suction, compression, expansion, and exhaust.
Okay. Suction stroke, compression stroke, expansion stroke, and exhaust stroke. Correct.
Yes,
Can you
sir.
explain
Yes.
one by one all the strokes? What all happens in suction stroke and what happens in compression? What happens in expansion and in exhaust stroke?
Sir, in suction stroke, the full vapor in correct proportion is supplied to the engine cylinder.
Okay.
In compression stroke, the full vapor is compressed in the cylinder, and in expansion stroke, uh, expansion stroke also known as power stroke, where power is produced when the fuel is compressed. When the fuel is compressed and when combustion takes place, it push the piston to the BDC, so that we get the power stroke. So that is how our crankshaft rotates. And exhaust stroke, when piston move from BDC to TDC, it expel out all the burn gases from the cylinder.
Okay. So these are the four strokes of four-stroke engine, right?
Yes,
So
sir.
let me explain one by one. First one is the suction stroke or intake stroke. Guys, here what happens is the air fuel mixture. In case of petrol engine, the air fuel mixture enters into the cylinder or the chamber, that is known as intake stroke or suction stroke. At this stage, the piston from TDC moves to the BDC. Okay, because the fuel has entered into the chamber, forcing the piston to move to the TDC. Okay, this is the suction stroke or intake stroke. Next one is the compression stroke. What happens in compression stroke? When the piston from BDC to moves to TDC, there is a temperature increase and the pressure increase inside the cylinder. Okay. Due to the increase in temperature, the fuel mixture, air and fuel mixture gets ignited, which results in expansion stroke. There is a blast happens inside the cylinder once the fuel is ignited. Okay. Due to this ignition, the piston from TDC moves back to the BDC, which is known as expansion stroke. Okay. And in exhaust stroke, the burnt gases, remaining gases inside the cylinder, moves out of the cylinder to the exhaust valve. Okay. Guys, you can differentiate between the diagrams of two-stroke engine and four-stroke engine. Here I have shown you the diagram of four-stroke engine. Can anyone say what is the difference in two-stroke engine and four-stroke engine diagram? Earlier you have seen the diagram of two-stroke. Now this is the diagram of four-stroke.
Sir, in two stroke there was port, and in four stroke it is valve, and in two stroke, yes sir, in two stroke there was port, and in four stroke it is valve.
Okay. Yeah. Can anyone tell me is two-stroke engine more efficient or four-stroke engine more efficient?
Sir, two stroke is more efficient than four stroke.
Okay. Anyone? Guys, there are hardly two or three members picking up.
So two-stroke engine is more efficient.
Okay. Why two-stroke engine is more efficient, not four-stroke?
Sir, four-stroke engine is so complex in design. So we can modify the two-stroke engine by increasing the stroke length. In marine field, we know the stroke length, the piston moves so long. So we can add more fuel and more we can burn more fuel. So to get more power, and by increasing the RPM of a engine, by which we can get more efficiency through the engine.
Okay. So four-stroke engine produces more power or two-stroke engine produces more power?
Sir, as compared to four stroke, two stroke produce twice power than a four stroke engine.
Okay. If two-stroke is producing more power than four-stroke engine and four-stroke is producing less power as compared to two-stroke engine, then whose efficiency is more?
Sir, can you
Sir,
repeat again?
can you repeat, please, sir?
You guys said that two-stroke engine produces more power as compared to four-stroke engine, right?
Right.
Yeah.
Yes, sir.
Then whose efficiency is more? Two-stroke engine efficiency is more or four-stroke engine efficiency is more?
Sir, two stroke.
Okay. So look into it once again, guys, because I think that in two-stroke, if you are increasing the power, with to increase power, we need more fuel. Okay. If you are burning more fuel, then efficiency decreases. I think. Look into it once again. I will also look into it once again. Okay. I think four-stroke
Okay, sir.
engine is more efficient than two-stroke because in four-stroke the stroke length is less, and in two-stroke the stroke length is more. Obviously, power output of two-stroke is more. Power output of four-stroke is less, but the efficiency of four-stroke is more as compared to two-stroke engine. What do you mean by efficiency, guys?
Sir, the thermal efficiency is more in four stroke engine as compared to two stroke engine.
Okay, yeah, thermal efficiency. I am speaking about overall efficiency.
Sir, then four-stroke is more
Yeah, overall efficiency of
because
four-stroke engine is more as compared to two-stroke engine, right?
right, yes.
Yeah, Harsh, you were saying something.
Sir,
Yes, sir,
because
you're right.
it has better avenging in four-stroke, the it has better it's scavenging,
Okay.
and the thermal efficiency is also high.
Yes. So what is the
Yes, sir.
conclusion? Whose efficiency is more?
Two stroke,
Four
sir.
stroke.
Four
Sir,
stroke,
four
four stroke.
stroke.
Sorry, sir. Four stroke, sir.
Yeah, four-stroke engine's efficiency is more, right? So guys, you mentioned that in two-stroke we can change the stroke length according to our wish, and two-stroke the stroke length is more as compared to the four-stroke. Can anyone say me why do we need to increase the stroke length? What is the purpose of increasing the stroke length?
Sir, to burn the fuel completely, sometimes on shipboard we use the bad fuel, so it takes a long time to burn. So that we increase the stroke length so that it can burn full and it can produce power completely.
Yes, correct. So is there anyone who wants to answer in a different way, or do you have any other answers? Why the stroke length is increasing two-stroke engines? Anyone? Okay. Guys, Arpan Roy was right. His answer was right. The stroke length is increased because we need to burn the fuel completely. In ship, sometimes we use heavy fuel oil is used to burn. Sometimes the quality of fuel is good. Sometimes the quality of fuel is bad. To burn it completely, we need time. To increase the burning time, we need to increase the stroke length, and also it is to increase the power, obviously. And as the stroke length increases, the consumption of the fuel also increases. And as the fuel consumption increases, the power is also increased. Okay. So there are two reasons: to increase the power and to um, burn the fuel completely, because it needs more time if the fuel is of bad quality. Okay. So these are the two reasons to increase the stroke length. Is there any doubt in this? Anyone?
No, sir.
Okay. So shall we continue to the next part?
Yeah.
Yeah.
Yes,
So
sir.
we have discussed about two-stroke and four-stroke. This was the classification of IC engine based on the strokes. That is two-stroke and four-stroke. So up till this, is there any doubt?
No, sir.
Okay. So next one is based on fuel used. Guys, based on fuel used. Anyone who wants to say? I have already shown you this slide.
Sir, based on fuel use, it is of petrol engine, diesel engine, heavy fuel oil, gas engine, and mixed oil, mixed type of engine.
Okay. So I have
Sir,
shown you the diagram. Yeah, yeah, Harish.
sir, then as it mentioned in slide, it is HFO.
Yes.
Marine residue fuel means
Sorry?
marine residue fuel.
Marine residue fuel. Where is it mentioned?
Sir, it is mentioned, not mentioned here, but I am asking in general. Uh,
I am exactly not clear about marine residue fuel. Harish, I will get back to you once this session is done. I will also find it. I also don't know
okay,
what the marine residue fuel is. Is there
okay,
anyone
okay,
who
okay.
knows what do you mean by marine residue fuel?
Residual fuels are that fuel which is left after crude oil refining. Okay.
Oh,
Once we refine, we take this gasoline, petrol, and all, naphtha, kerosene, and all. What is left behind, which is still liquid. After that, we will get bitumen, right? Tar, what we call
yes.
tar, we use for tarring, right?
Yes.
The remaining thing that's on the top liquid, that's called residual fuel. HFA is type of a residual fuel. Okay, got it?
Yeah. Thank
Yes,
you, sir. Actually, guys, sir is already a sailor. He is having experience of sailing. Sir is, I think, a fourth engineer now. So thank you so much, sir, for correcting our answers and attending this meeting.
Always, always. Thank you.
Yeah. Guys, I hope you guys are clear with what do you mean by marine residue fuel.
Yes, sir. Clearly.
Yeah. Guys, I have shown two diagrams showing the petrol engine and diesel engine. Can anyone figure out what is the difference in those two diagrams?
Sir, in petrol engine, the spark plug is used, and in diesel engine, it is nozzle is used to spray the fuel inside the combustion chamber.
Okay. Apart from
And
that, yeah.
fuel used in
In such
petrol engine is petrol, and in diesel engine that is diesel.
Okay.
In suction stroke petrol engine, only air and fuel mixture is entered. In diesel engine, only air is entered.
Yeah, correct. That is the important difference, guys. In petrol engine, the mixture of air and fuel is entered during the suction stroke, whereas in diesel engine, only air enters. And during the compression stroke, the diesel is injected. So that is the difference between petrol engine and diesel engine.
Compression ratio is uh,
Sorry?
in petrol engine. Compression ratio is low compared to diesel engine.
Yes. So, as we are discussing just the basics of the IC engines today, we'll discuss about the difference between petrol engine and diesel engine and also the difference between two-stroke and four-stroke in detail in the upcoming sessions. Okay. So this was just the basic of IC engines. Okay. So shall we move to the next part, guys? We have discussed based on stroke. Now we have discussed based on fuel used. So we will move to the next part, that is based on the action. There is single acting cylinder and double acting cylinder. Can anyone say what do you mean by single acting cylinder and what do you mean by double acting cylinder?
So the charge is admitted only on the one side of the piston, that is single cylinder, and double cylinder. The charge is admitted to the both of the side, and it produces one suction stroke as well as discharge stroke also at the same time.
Yes. So that is the difference between single acting and double acting. So here I have shown the reference image. This is not the actual image or actual diagram of the double acting engine. This is the double acting cylinder, just a cylinder. Okay. So wherein the suction takes place from one side and the discharge takes place from another side. Whereas the discharge takes place from one side and the suction is taking from the other side. So both the actions are happening at the same stroke in the cylinder. That is known as the double acting cylinder. Whereas in the single acting engine, what happens is the suction happens in one stroke and the discharge happens in another stroke, right? Whereas in double acting cylinder, both the cycles are happening in the same stroke. That is the difference between single acting engine and double acting engine. Is there any doubt in this?
No, sir.
Okay. So shall we move to the next part? Yeah. Based on air intake. Can anyone tell me based on air intake? I have already shown the slide. You guys can refer the diagram as well. Guys, please speak up. I have
Sir,
already
it is
shown
of
you the
two
slide.
types.
Yeah.
Sir, it is of two types. One is natural aspiration, and one is supercharger. In natural aspiration, it is suck the air into the cylinder due to the pressure difference between the cylinder and outside and atmospheric pressure. And in supercharger we use the exhaust gas uh, to exhaust a little bit. I am confused, not remembering right now.
Okay.
Sir,
In
in supercharged
turbocharger only
engine,
we use exhaust gas. In supercharger we use a blower where the two pulleys from crankshaft to the blower pulley it is connected by a belt drive. through which the air is sucked in, that is supercharger. Natural aspiration is straight away it takes the air inside. That is the difference between supercharger and natural aspiration.
Okay. Yes. Based on air intake, guys, basically there are two types. One is a natural aspiration and another one is supercharged. In natural aspiration, what happens is the air is sucked from the atmosphere only. Okay. Due to the pressure difference, as Arpan Roy mentioned, due to the pressure difference of the engine cylinder and the atmospheric pressure. The air which is getting sucked in the natural aspiration is not that forced air. It is naturally getting aspirated. Okay, due to which the fuel burning is not that efficient. Okay, whereas in supercharger we are using the compressor or pumps to induce the air with the force inside the cylinder. We induce the fresh air, due to which the combustion takes place completely and the power generated is more. Okay, that is why in supercharger or turbocharger we get more power as compared to the natural aspiration engine. Is there any doubt in this? Hello.
No, sir.
Sir, how does it suck the air in supercharger process?
Yeah, in supercharger what happens is actually in supercharging we have two types. One is turbocharger and another one is supercharger, right? I will explain you not in deeply, just I will give you an idea, okay? Because we are going to discuss about supercharger, turbocharger in upcoming sessions. As you have asked, I am going to explain you. In turbocharger, what happens is the exhaust manifold, the exhaust gases are used to rotate the turbine, okay? And that turbine is connected to the compressor, which rotates the turbine. The exhaust gases are coming from the exhaust manifold, which is rotating the steam turbine, and that steam turbine is connected to the compressor via shaft. And as the compressor rotates, it is sucking the air from the atmosphere and compressing the air and pushing that air forward to the cylinder with the higher pressure. Okay, this is the turbocharger. Whereas in supercharger, what happens is the compressor is directly connected to the crankshaft. There is the exhaust gases are not being used there. The connection between compressor and crankshaft is used in the supercharger. So that is the difference between supercharger and turbocharger. Okay. Is there any doubt, Arpan?
No, sir, clear.
Yeah. Atul Raj sir, is there any mistake I have made, or is it right the way I am explaining?
Yeah, you are correct. But which one is efficient? Supercharger or turbocharger?
Guys, which one is efficient, more efficient? Supercharger is more efficient or turbocharger is more efficient?
So turbocharger, sir.
Why?
Sir, because supercharger uses engine's power as well, so it efficiency will reduce compared to turbocharger, where turbocharger use only exhaust gas to pump in, suck in the air. So that's why turbocharger is more efficient compared to supercharger.
Okay, but in case of turbocharger, what happens is it will take it some time, right? Till the engine starts, exhaust gas develops, then pressure develops. So it will take some time. That time is called turbocharger delay. Okay, so there is disadvantages for both and advantages for both. And in on ships we use turbocharger. There is no supercharger on ships. We use turbochargers for main engine also and auxiliary engine also. That's because we want to recover the maximum heat. See, when we inject fuel into the engine, the uh, engine is not taking all the heat. It's releasing heat with the exhaust gas, right? Exhaust gas, it is already heated. So the heat is getting waste. So we don't want to waste that heat. So we use that heat to run the turbocharger so that we can get maximum efficiency from the exhaust gas. This is what happens. And what happens if something is compressed?
Sorry, sir.
What, what happens if something is compressed? If air is compressed, what is actually happening?
Yeah,
Its
guys.
temperature also increases.
Temperature
Sir, its
increases. Okay.
pressure and
Temperature also
temperature
increases.
increases.
Pressure and
Correct.
temperature increases. Okay. Then what about volume?
Sir, knocking.
No, I'm
Sir,
asking about
volume
volume. What about volume?
Volume
sir,
Sir
decreases.
is asking about
sir,
properties.
volume decreases.
What
Volume
about volume?
decreases,
I,
sir.
I didn't get. Volume decreases, right? So you have
Yes,
studied about density, right? Density is equal to mass divided by volume,
Yes.
right?
yes,
So what happens? More volume is reduced, keeping mass constant.
Density increases.
Density increases. So if we use supercharger or turbocharger, we can introduce air or much denser air into the cylinder.
yes,
Okay.
sir, yes, right.
Now the
Yes,
volume is reduced, pressure is increased, the density is increased.
Correct.
So we can
yes, sir,
introduce
right, right.
more denser air into the cylinder. So the density increases. Thereby we can introduce more cylinder and the engine can be run in more efficiency.
Yeah, yeah, right, sir.
Got my point?
Yeah,
Yes,
yeah,
sir.
yes, sir.
Okay, thank you.
Yeah. Thank you so much, sir. Guys, is there any doubt about supercharger or turbocharger?
No, sir, no.
Okay. So next one is based on number of cylinder, guys. Based on number of cylinders, we have two types, that is single cylinder and multi-cylinder engine. Okay. So I think there should not be any doubt. The picture itself explains what do you mean by single cylinder engine and what do you mean by multi-cylinder engine, right? Or is there any kind of doubt in this? Anyone who has doubt
No, no.
about single cylinder or multi-cylinder? In single cylinder, we have only one cylinder and one piston. Okay, so that is the single cylinder engine. And in multi-cylinder engine, we have got multiple cylinders arrangement inside the engine based on the power requirement. Okay, based on the engine design, that depends on many other factors. That is the meaning of multi-cylinder engine. Okay,
Okay, sir.
yeah. So next one is based on piston pattern or cylinder pattern. There is V type engine, W engine, X engine. I hope you guys have heard about the supercars, that is V12 engine, W12 engine, V twin engine. What do you mean by these? What do you mean by V12 engine or V6 engine, V8 engine?
Sir, V6 means six cylinder.
Correct. Six cylinder in what pattern? Is it a six cylinder in inline six,
No, no,
flat
radial
six?
pattern.
Okay. Actually, V6 means we have piston in the V shape. Okay. V means
Yes.
we have piston arrangement in V design. Okay. We have such six cylinders. One, two, three, four, five, six. Total, there are three V shapes. That means one, two, there is three, four, five, six. That is the meaning of V6. Okay. The piston arrangement is arranged in such a way that it looks like a V. Okay. That is the V shape engine, V engine. Similarly, it goes for W engine, X engine. You guys can refer that diagram. Is there any doubt in engine patterns V, W, X? Guys, can you give me an example of V twin engine in a regular day, a regular where you have seen V twin engine? It is used in a bike. V twin engine. Anyone? There are many bikes of V twin engine. Usually 350cc, 400cc, 600cc. Nowadays, V twin engine is used. Anyone? Have you guys seen Royal Enfield Classic 350 or
Sir,
all
interceptor.
other? Yeah, Interceptor. There are many other bikes, super bikes nowadays are using V twin engine. Earlier also they were using V twin engine only. I hope you guys have observed that piston arrangement. Have you guys seen it? No? Anyone? Okay, no issues. So guys, this was about the piston arrangement. So next we will move to the next part, that is based on engine RPM. Engines are also classified on their RPM, that is low speed, medium speed and high speed. Low speed varies from 100 to 350 RPM and medium speed varies from 350 to 750 RPM and high speed varies from 750 to 2500 RPM. I hope guys you know the meaning of RPM. What do you mean by RPM?
Sir, rotation per
Revolution per
minute.
minute.
Okay. Rotation per minute of,
Crankshaft.
okay. Yeah. Rotation per minute of crankshaft. That is how the engines are also classified based on the speeds. Okay. Low speed, medium speed and high speed. Okay. So is there any doubt in this?
No, sir.
Anyone? Okay. So next one is based on mean piston speed. As I mentioned earlier, the average speed of the piston throughout the cycle is known as the mean piston speed, right? Based on that mean piston speed, also we classify the engine as low mean piston speed, medium mean piston speed, and high mean piston speed. Okay. In low mean piston speed, we have got it up to 4.5 to 7 meters per second, and in medium piston speed, we have 7 to 10 meters per second, and in high mean piston speed, we have 10 to 15 meters per second. Okay. So that is about mean piston speed of the engine. That's also how it is classified. Is there any doubt in this? Anyone? Hello?
No, sir.
Okay. So guys, next one is based on engine movement. That is unidirectional and reversible engine. Can anyone say what do you mean by unidirectional and reversible engine? Anyone?
Unidirectional engine is the engine which moves in the single direction. It can't move in the reverse direction. And the reversible engine, it can move in forward direction as well as in backward direction also.
Okay. So in cars, that is four wheelers, we use unidirectional engine or reversible engines.
Unidirection engines.
But car moves in reverse as well.
Gearbox.
For due to gearbox.
Okay.
So due to
So
the
in
arrangement of gears.
yes, correct. So that is due to the arrangement of gears, right? Whereas the crankshaft rotates in the same direction. But in reversible engine,
Yes.
the crankshaft rotations can be altered in the reverse direction. Okay, that is the difference between unidirectional engine and reversible engine. Four-stroke engines are unidirectional engines. Four-stroke engines cannot be reversed, whereas two-stroke engines can be reversed. Only two-stroke engines. Okay. For example, the main engine of the ship. Main engine is a reversible engine, whereas the auxiliary engine is a unidirectional engine. Okay. Is there
Yes.
any doubt?
Yes, sir.
Guys, any doubt about unidirectional and reversible engine?
No, sir.
Not at all, sir.
Okay. So, guys, that was about today's discussion. So, I have noted some of the questions which may come from today's discussion. So, these are the interview questions which you may face. If you guys want, you can take the screenshot of it or you can note down the questions. So, that is the end of topic for today's sessions. So this was all about basic introduction to the IC engines. From next session onwards, we'll go in deep and in more technical knowledge about IC engines. We'll discuss more of IC engines. Okay. So guys, I want to know, I want to have the feedback about today's session. Is there anyone who want to give any feedback? Do you guys need any improvement in communication or do you guys need any improvement in the way of explaining? Any feedback?
It was good, sir.
Okay. If it is
Sir,
good,
can
you
we
can
get
say,
recorded video?
yeah, this recorded session will be uploaded in the official Merchant Navy Decoded channel.
Okay, sir.
Yeah. Other than this, is there any doubt, guys? Do you guys want me to make any improvement in my session, or you want to give any inputs to me?
Sir, weekly thrice these kind of discussions will be more essential for our interview preparation as well, sir.
Yeah,
So
correct.
from different topics, from like today you taught IC engines,
Yes.
later we can have topics from refrigeration, AC, compressor as well. So weekly thrice this kind of session will be more crucial for our interview process.
Yeah. Okay, Mikey, we will look into it. We will talk to the team. Actually, currently only 2 weekly sessions are allotted for me. I will talk to my team and try to increase the weekly sessions so that it can help you to the to clear the interviews. So what we'll do is now on. I have Today we have taken the session only on basics of IC engines, right? That is the introduction to the IC engines. In later on parts, we will discuss in deep about turbochargers, about scavenging, about superchargers, and all the other factors, including the IC engines. Okay, about the IC engine fuel system, IC engine lubrication system, IC engine air system. So there are many topics to be discussed on the IC engines. Why I have chosen the part IC engines only? Because there are many questions coming in the interview based on the IC engines only, and also in the written part as well. Okay, so first we will cover all the topics from the IC engine, and once the all the topics are covered, then we'll go on to the next topic, that is boilers, refrigeration, air compressors. Okay, we'll cover one by one.
Sure, sir.
Yeah. So other than this, is there any doubt on today's session? Anybody?
No, sir.
Yeah. So these were the topics taken from the Dreamers package, guys, and also the GME Excellence packages. So if you guys don't have any of these packages, I urge you to take the GME Excellence package, especially for your GME preparation. It is designed to clear your interviews and written, and all the topics are explained in a very basic manner by Pranit Mehta sir. So thank you guys for attending the session. Hope to see you guys soon in the next session. Take care. And also, I urge all of you to take a look into the next part of the IC engine from the GMA Excellence package. Refer the GMA Excellence package as much as possible. Okay.
Thank you, sir.
Yeah. Thank
Thank
you,
you, sir.
guys. Yeah.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you. Take care.
Thank you, sir.
Yes.